Hi students, this is Miss Vella, and we're going to go through some of these Punnett squares. I know that doing sex-linked Punnett squares can be a little bit challenging, so that's why I'd like for us to go through these. Number one, hemophilia is due to a sex-linked gene. So as soon as you see the word sex, you are going to want to remember that there's XX for females and XY for males. It is recessive and found on the X chromosome. A woman who is a carrier for hemophilia marries a normal man. What will be the possible phenotypes of their children? Use the letter capital H. Okay, so let's put the let statement. So let H be normal and little h be hemophiliac. Now let's look. We have a normal woman. This is the symbol for a woman. So if she is normal, a woman who is a carrier. Now, when you see carrier, it means that she does not have hemophilia. So if she does not have hemophilia, she has at least one capital H. But if she is a carrier, then she has little h. All right, so she is able to clot her blood, but she is the carrier. Now, the male that she marries, he's a normal man. Well, if you look at his sex chromosomes, he has only one X chromosome. So the only way that he can be a normal man is if he has capital H. All right, I'm going to switch up the color to do our Punnett square. So remember when you're doing a Punnett square that you're going to have one of the parent's offspring, or one of the parent's gametes on one side, and then the other side going up, you're going to have the other gametes, okay? So it doesn't matter where you put the male or the female. The females I'm going to put at the top. So this is what her genotype is, okay? I'm going to put one of her sex chromosomes beside her other sex chromosome. Okay, so do you see how I did that? I broke apart both of her sex chromosomes. Now for the male, I'm going to do the exact same thing. Okay, now let's start putting in the sex chromosomes. So do you see how for the row with the capital H from the male, I put them both there. Now I always put the Y, the second letter, so that's why I'm changing it. And then I'm going to put the female's sex chromosome there. Okay, so there's our Punnett square. It says, now, what will be the possible phenotypes of the children? So because you're looking for phenotypes and not genotypes, we have to write that out. So let's see. We have possible phenotypes. It's not asking us for a percentage, but we have, so let's look at this one here. This is going to be normal female. Sorry, there's no E. Normal female. What about this one to the right of it? That's also going to be a normal female. She's a carrier, but her phenotype does not show that she's a carrier. Let's look at this genotype. It's a male, and he's normal. So we have normal male. And then our last one is going to be a hemophiliac male. You see the two parts to answering if what the phenotype is going to be for sex-linked chromosomes. Normal, which is showing the genotype or as represented in the phenotype, and then the sex. So you have to say normal female, hemophiliac male. You need those two parts for a for the phenotype of a sex-linked gene. Let's move on to number 2. A phenotypically normal male. So let's highlight the parts that are important. A phenotypically normal man who has a hemophiliac brother marries a normal woman who is not a carrier. Okay, so that's important, not a carrier. What is the probability that any of their children will be hemophiliac? Okay, so let's start off with the easy part, the normal female. So I'm going to use this symbol again for female. So if she's normal, she has at least one capital H. But this part here, she's not a carrier. Does that mean that the second letter here, is that a capital H or a lowercase h? It's going to be capital H. That means both of her genes are normal. Now this part over here, the first sentence, it says a phenotypically normal man. We know that for a male, it's XY. So each male only has one chance to have the hemophiliac gene. Does he have it? No. How do I know? Because he's a normal man. Because he's a normal man, it's going to be capital H. Let's do our Punnett square. So I'm going to put the female's the female sex chromosomes at the top. So she has both dominant normal genes, and the male is going to be on the bottom. And his chromosomes, this is what he has. Okay, so take a second, fill it out. Let's take a highlighter. Can you highlight all of the hemophiliac children? Now remember, in order to have hemophilia, you have to have the lowercase h. So am I going to highlight anything? No. So the correct answer when it's asking, let's read what is the question asking? What is the probability that any of their children will be hemophiliac? Well, this child is not hemophiliac. This child's not hemophiliac. No and no. So 0 out of 4 children, or 0% chance. of their children having hemophilia. Okay, so have a look at the other questions and then we'll come back.